let's pick up from where we left off with floats. Um, Floats are strictly IEEE compliant unless optimized is used, equivalent to GCC's FastMath. Floats coerce to larger float types. So we need to, oh my god. Um, okay. So, floats can coerce to larger float types. So, as long as that number is bigger than the thing you're trying to coerce to, it should be fine. Meaning that this test should pass. Since 32 is bigger than 16 and 128 is bigger than 32, there should be no issues there. Both support multiple kinds of literal. That's basically just the notation of which you can use them. So these are all the same number. Just this is the standard one. This is scientific notation. This is also scientific notation. Those are all hex. Okay. Nothing too crazy. Underscores may be placed between digits. Not really sure what the oh, never mind. That's simply for the coders. So instead of having like 100, oh my god, 100,000, you would have 100,000. So that's nice to read. Floats support multiple kinds of literal and underscores. May be placed between digits. Integers and floats may be converted using built-in functions. Float from int is always safe because it will just put .0 basically. Int from float is detectable illegal behavior if it cannot fit in the destination. So if you had a F64 to an I32, that would not work. I believe that is what that means. Here, let's run that and see if Uh, 82. What's the problem here? Expected type expression found invalid token. What if I do that? No? Okay, that's kind of weird. Is it because of the spaces? Why is it suddenly upset? This was perfectly fine the last time I looked at it, but oh my god. Okay. Expected type expression found invalid token sig comment. No tabs allowed. 90. Okay. 0 to 90. We're going to replace tab with space. There we go. Okay. Moving on. Oh, that's annoying. Integers and floats may be converted using the built-in functions. Is always safe. Yeah, okay. Makes sense. 14. So, yeah, let's try this again. So that's not what I wanted to do. I wanted to do zig test. Should be one fail. Yep. Okay. Moving on to labeled blocks. Blocks and zig. Blocks and zig are expressions and can be given labels which are used to yield values. Blocks yield values which mean they can be used in place of a value. The value of an empty block is a value of type void. Meaning they can be used in place of a value. The value of an empty block is of type void. Okay. Do-do-do. Nope. Wrong spot. Labeled blocks. So what's going on here? Count is equal to, and then this is the label, not the actual, like this could be called anything. So I change this to, I don't know, testing. This is now a block called testing, and then we have a sum and a variable. So while I is less than 10, I plus equals 1. And then sum plus equals I. So that's going to be 10 factorial, which is 10 factorial. That should be 45. No. Right, factorial is times. 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus... Again, that should be 45. 55. 3, 6, 10, 15, 21, 28, 36, 45, 55. Okay, so this is going to fail. And then once I equals 10, it will break to here and return some. And then this will be equal to 55. If I'm reading that correctly, the type of count is not explicit, but the return value here is a U32, so it should also be a U32. I'm pretty sure that's going to fail though. 2 failed. 1 failed. Okay. And then Zig doesn't have the plus plus, so we have to do plus equals 1. Which is a little annoying, but the whole thing of Zig is that it's super explicit, so that makes sense. Labeled loops are going to be much the same. Um, I don't know, is there even anything to... Um, loops can also be given a label. Allowing you to break or continue to outer loops. Simple enough. So I guess I'm just going to call this... I guess that can still be labeled block. A loop counts as a block. Inferred size, discarded value. Not really sure how that's going to be equal to 8, but also I'm going to get rid of that. That's really annoying. Okay, so why does this mean 8? So 4, 1, 2, 3, 4, 5. Going to do that and then count. And 1 through 8. So it's going to count for all of those. Shouldn't that be 15? Or 25? Because it's going through 5 and adding 1 for the first 5. I guess it would go to the whole way. How does that equal 8? It's because I'm stupid. So, boom. Goes to here, counts 1, adds 1, continues to outer. So that's going to skip to here. And then it's going to do the same thing. Okay. Loops as expressions. Like return break accepts a value. This can be used to yield a value from a loop. Loops in Zig also have an else branch, which is evaluated when the loop is not exited with a break. Good. Stop highlighting, please. So begin and number So if it equals the number, it will break true, otherwise it will return false. 0 to 10, 3 is the number, so that will return true. Means it should pass. Break accepts a value, and this can be used to return a value from a loop. If the loop is not exited with a break, then the else clause is executed. Optionals. Um, Optionals support the or else, which acts when the optional is null. This unwraps the optional to its child type. So fallback value is 0. Const b equals a or else fallback value. Since that's null, it'll be equal to 0. Okay. And then here, it can be a null or usize, we're making it null. Data is an inferred size array, I32 of these. We're going to loop through data from 0 till the end, store the value and the index. And if v equals 10, found index equals I, there is no 10, so that will be true. Dot question mark is a shorthand for or else unreachable. This is used when you know it is impossible for an optional value to be null, and using this unwraps a null value. And using this to unwrap a null value is detectable illegal behavior. So this will never reach this, and that will be So this will all be 5, and then since these two are 5, that will pass. And F32, since it's not unreachable, that will pass. Okay. Shorthand for or else unreachable, and is used when you know, oh my god, no, it is impossible, possible for an optional value to be null. Which, I mean, if it's impossible for it to be null, why would it be optional in the first place? Who knows? Using this to unwrap a null value is detectable illegal behavior. Or else unreachable, both if and while support taking optional values as conditions, allowing you to capture the inner non-null value. Here we use an if optional payload capture. A and B are equivalent here. If B value captures the value of B, in the case where B is not null, and makes it available as a value. As in the union example, the captured value is immutable, but we can use a pointer to modify the value stored in B. Okay. So A is an optional I32. It equals 5, so if it's not equal to null, it's not here. The value is going to be 5, and then discard the value. B is also an optional I32 equal to 5. If B catch pointer value dot actual value, so like the dereferenced value of B here, plus equals 1. So that should be 6 here. And it is. Then here's the while loop version. So sum is a U32 equal to 0, while eventually null sequence. So run this function, capture the value, sum plus equals the value, try expect sum equal to 6, and then the function returns an optional U32, so it can be null. If numbers left equals 0, return null. Numbers left minus equals 1, return numbers left. And then here it's equal to 4. Yep, makes sense. Optional pointer and optional slice types do not take up any extra memory. This is because internally they use the 0 value of the pointer for null. Interesting. This is how null pointers in Zig work. They must be unwrapped to a non-optional before dereferencing, which stops null pointer dereferences from happening accidentally. Null pointers must be unwrapped to a non-optional before they can be dereferenced. And optional pointer and slices do not take extra memory as they internally use the 0 value for the, oh my god, I can't type today, for the pointer to null. Comp time. Which, besides for optionals, is like a big selling point of Zig. Comp time. So blocks of code may be forcibly executed at compile time using the comp time keyword. So here we're just doing the Fibonacci. These will be the same, obviously. Comp time means it runs this at compile time. Duplicated struct Fibonacci 207. That it is. I guess I don't need to do that. I can just from here plus 12 Fibonacci to fib dash G. So I don't really understand how it does that at compile time, but integer literals have, oh my god. Integer literals are of the type comp time int. These are special in a way that they have no size. unless they can't be used at runtime, and they have arbitrary precision. Comp time values coerce to any integer type that can hold them. They can also be coerced to floats. Character literals are of this type. Ref type comp time int. CF dot and are special because they have no size and they have arbitrary precision. Okay. So comp time int. Why are these comp time? It doesn't, we're not using the keyword here. Sure. It's because we're not giving them an explicit type. I will have to come back to that. I don't really. Why are these comp time? Comp time floats are also available. Internally, they're in F128. They cannot be coerced to integers even if they hold an integer value. Fair enough. Types in Zig are values of the value type. These are available at comp time. Previously encountered them by checking type of and comparing. But we can do more. So branching on types. A is equal to 5 if A is less than 10, F32, else I32 equals 5. Okay. That was a little confusing, but I think the control flow here is that. So it will equal 5. And then it will be an F32 because A is less than 10. If I'm understanding that correctly, and apparently I am. Function parameters can be tagged as being comp time. This means that the value passed to the function parameter must be known at comp time. Pascal case as it returns a type. Um, okay, what's going on here? So comp time t is a type. Width and height are both comp time ints. Here, let's make that easier to read. So these are all the parameters. And then it returns a type, and it will return height and width t. And then returning a type. Matrix F32, so that's the type. Height and width is 4, and it will return a 4x4 matrix of that type. Okay. Nothing too crazy there. We can reflect upon types using type info, which takes in a type and returns a tagged union. This tagged union can be found in std.builtin.type. Info on how to make use of blah blah blah. And returns a tagged union. Not really sure what that means, but suppose we're about to find out. So we take a type, and then those are all the same. And then we return a switch. So if they're comp time ints, we'll do a plus b. If it's an int, we'll capture that as info. And then if int.bits is less than or equal to 16, so it's a U16 or less, we will return a plus b. Otherwise, int too large. I'm just gonna change this a little because that's not great to look at. Never mind. So if it's less than or equal to a U16, a plus b, otherwise it's too big. And then what am I doing? And then if we don't pass it in int, it will say ints only accepted. So then here we're going to add a U16 of 20 and 30, so it should return 50 and U16. which it doesn't. No field name, comp time, int. I don't know why this isn't working. Oh well. If it doesn't work, get rid of it. We can use the type function to create a type from a type info. Type is implemented for most types, notably unimplemented for enums, unions, functions, and structs. That is useful. To know. Here, anonymous struct syntax is used. Because the T and T can be inferred, anonymous structs will be covered later. We will get a compile error if the int tag isn't set. So we get comp time type, we return a type. And then if it's an int, we get the bits. We add one, and then we get assigned. So that would be unsigned or signed. Okay. And then we just add one to the bits. So U8 becomes U9, I31 becomes an I32. 719, is that where I'm at? Yeah. So I don't know why these aren't working. But yet again, just comment it out. Returning a struct type is how you make generic data structures in Zig. The usage of this is required here, which gets the innermost struct, union, or enum. Standard mem equal is used to compare two slices. Not where I wanted that. So that's how you do like the self dot whatever stuff. So we're getting a comp time count of comp time int, as well as a comp time type, returning a type, and then we return structure, which has a data of count t. So this will make an array, and then self is equal to this. Absolute value of self, self, self. So it's a function. It takes in type self, which will be this, which in this case will be the struct. Returns self. Sets the data to undefined. For 0 to the end, we get the element and the index. If data I, no, we set data to I. If element is less than 0, we set it to the negative value. Otherwise, we set it to the positive value. Returning temp. Then init just initializes that. Equal is equal to that. So here we have a vector 3f32.init. We give it an inferred size, and then the type is f32. 10 minus 10, 5. And then here we do absolute, which will return okay, never mind. So here it multiplies it by -1 to get the positive. So this returns the absolute values of that. Yeah. Types of function parameters can also be inferred by using any type in place of a type. Type of can then be used on the parameter. That seems not very helpful. I guess if you wanted like a true generic, so to say, that would be so it takes in any type, returns the type of x plus 1, and then we're sending it as a U32. Okay. Comp time also introduces plus plus and star star for concatenating and repeating arrays and slices. Actually, something that might be good. So here, this is undefined. That's going to be a bunch of undefined. Because it's a slice of start to end of x, which is undefined, and then same thing here. Y plus plus b. So all be undefined, but it will have a length of 10, because we're concatenating those two. This would work if it was Rx, Ra as well. And then repeating. So this is an inferred length, U8. Those are just some random hex values. Memory is pattern repeated 3 times. Try expect equal U8 and memory, which should be true. Yeah. I guess I should make a little note because these are important. Repeating array slash slice. Concat array slash slice. Payload captures. Okay. I'm going to take a little break. I'll be back in a couple minutes. Probably not more than 5. Okay. I am back. Payload captures use the syntax pipe value pipe and appear in many places. Seen some already. Used to capture the value from something. Um, so here maybe num is an optional usize equals 10, so it's not going to be null, which means that will be true, that will be true. Also unreachable, which it will never reach. Yeah. So payload captures use this syntax and are used to capture the value from something. With its, oh my god. With if statements and error unions, the else with the error capture is required. So unknown entity or a U32 is equal to 5, so it's going to be a U32. So if not null, we capture the entity. The type should be U32. Yep, value 5. Yep. Otherwise, we catch the error, discard it, and then say unreachable. I guess here it would make sense to also add a if error equals error unknown entity check, but it's not required, I suppose. Um, with while loops and optionals, may also have an else block. So here we have a sequence, inferred size, optional U8. The last element is null. That's interesting. So while sequence I capture the number I plus equals 1. So it's going to go through each element, check that it's a U8, which it will be until here. And then that should be 3. 1, 2, 3. And then if this equals null, which it will. Um, with while loops and error unions, The else with an error capture is required. What am I even on again? Payload captures. So numbers left is undefined, null or U32 return. If that equals 0, error.reach 0. Otherwise, we're going to jump to block. No, otherwise, this is a block, like a labeled loop type situation called block. Numbers left minus equals 1, and then break back. So that's going to keep running until it equals 0. And then 3. That's going to be 6 for the sum. And then here we're saying while this function runs, capture the value, add that to sum, which in this case returns that. And then otherwise we're going to catch the error and then see if the error is the error we said it should be. Yeah, okay. Simple enough. I think that can also be like that because it's not much. Actually, that should immediately return reach 0 because we're not passing numbers left 2 into it. Or would that be fine because Zig doesn't have the thing where you have to declare a function before you call it? I do not know. Let's add a std.debug.print. That should be fine. That's going to be value. Two one zero. Okay, so that is what's happening. Since you don't have to predefine functions, you can call them before or after they're defined. Kind of like how JavaScript has hoisted functions. Personally, I'm not a huge fan of that, but that allows us to, since we're changing this before we call the function, in the function, it will be this value. Okay. For loops. So inferred type I8, those values for x, excuse me, capture the value and see if it's an I8, which they will all be. That basically just means go through the whole thing. switch cases on tagged unions. I guess that would just be an inferred type. I'm not really sure. And then, oh, that's confusing. Okay. So B is of the tagged union. Yeah, it's going to set A to 10. X is going to switch on B. B is equal to string that is a labeled block. So if it's a string, which is an array of constant U8s, it will pass true and then break to block with 1. Okay, so X will equal 1. I'm still kind of new to the whole if statements as expressions thing. Dot C is equal to 2. If they're of the same type, they may be inside the same capture group. So that's not going to be 1. Because A is a U32. And then, since A and D are both U32s, we can capture them at the same time. Another labeled block. So num will be a U32, which means we break with num times 2, which in this case is 10, because A is 10, X equals to 20, so this should all be fine. And it is. I guess I can do that. As we saw in the union optional sections above, values captured with the syntax are immutable, so we can use a pointer capture to modify the values. This captures the value as pointers that are themselves still immutable, but because the value is now a pointer, we can modify it by dereferencing. So, captured values are immutable. The pointer, like where they point, is immutable. Like the actual address they point to is immutable. But if you dereference, you can change the value. Okay. Simple enough. So we're passing the address of data for the pointer to byte. Byte dereferenced plus equals 1. So 2, 3, 4. Yeah. Pretty not terrible. Values captured are are immutable, but we can use a pointer capture to modify the original values. This captures the values as pointers that are themselves still immutable. Yeah. Inline loops. Inline loops are unrolled and allow some things to happen that only work at comp time. Use a for, but a while works similarly. Using these for performance reasons is inadvisable. Compiler is smarter than you. Yeah. What am I doing? Inline loops. Stop highlighting. So we have an array of types of inferred length, and the type is type, obviously. Sum is equal to usize. Inline for types, so through the whole array, we're going to capture that as t, and then plus equals the size of t. Try expect sum plus equals 10. I'm gonna change this a little bit, and then also add type any size \n dot do t and size. Extra capture and for loop. Can you not do that? Where is an example of a multi-capture? There, blah, blah, blah. Yeah, just comma separated. And I see one in a for loop right here. That should be fine. Maybe the space matters? No? Okay, never mind. Why is that 10? I guess I should. Opaque. Opaque types in Zig have an unknown, albeit non-zero, size and alignment. Because of this, these data types cannot be stored directly. These are used to maintain type safety with pointers to types that don't have information available. What? What is going on? Okay. Do. Opaque. Uh, Opaque declared here. Zig.window, zig.button. Okay. So that's the same thing. Opaque types may have declarations. Um, Window to window, just so it doesn't get angry they have the same name. Don't know what extern does. I don't think we've talked about that yet. Don't know calling convention, that's just gonna say it's called the same as it would be in C. And then opaque cannot cast Zig window. Yeah, I don't. Not really vibing with opaque. Anonymous structs. The struct type may be omitted from a struct literal. These literal. Wow. These literals may coerce to other struct types. Um, Anonymous structs. So struct, that's equal to that. We're not giving it the type, but we are giving values. So I don't really like, is that in place of going point? Okay. May also be completely anonymous. So what is going on here? So dump. So this part is all the anonymous struct part. Try. Okay, dump is a function. Okay. Args any type, which means it will take anything, and it returns null, or not null. It returns an error or void. Here we have .int as u32, float as f64, b is true, s is high. So that will all work. I'm not really sure why you would ever want to have a completely anonymous structure, but it's kind of cool, I guess. Anonymous structs without field names may be created and referred to as tuples. They have many properties that arrays do. They can be iterated over, indexed, concatenated, and repeated, and have a length field. Internally, they have numbered field names that start at 0, which may be accessed using the special syntax. Blah, 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 acts as an escape for the syntax. Things inside ampersand quotes are always recognized as identifiers. Where am I? Escape for the syntax. Things inside are always recognized as identifiers. Anonymous structs are referred to as tuples. And can be iterated over, indexed. Yeah, okay. I guess that's kind of like a separate thing, but I'll keep it with that. An inline loop must be used to iterate over a tuple here, as the type of each tuple field may differ. Do you... Yeah, see, it works right here. Oh. Because I didn't understand how it works. Where is it? Sum plus equals, no. Switch capture, no. Here. For types, and then 0 dot dot size std.debug. Wow. Wow. Debug.print type any size t size do. What do you mean? How is this undeclared? Okay, whatever. Probably not like an actual rule, but that seems like a good thing to follow. 16 bum. So we have an anonymous struct, which since the fields don't have names, this is a tuple. And then we are concatenating false times 2. 0, 1, 2, 3. So 4 will be false. 0 is 1, 2, 3, 4. So 4 values. And then start to end. If I does not equal 2, continue. So 0, continue, 1, continue, 2. That will be true. Values.1 is 6. 1, 2, 3, 4. And then plus the 2 falses, that's true. So this will be the third spot, like the third index. Index 3. 0, 1, 2, 3. First character. Okay. Sentinel termination. Arrays, slices, and many pointers may be terminated by a value of their child type. This is known as sentinel termination. These follow the syntax entity t, 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 and pointer to t, where t is the value and... Oh my god. Okay. Um, known as sentinel termination. And follows the syntax. Example, built-in pointer cast is used to perform unsafe type conversion. This shows us that the last element of the array is followed by a 0 byte. So size 3 terminated by 0. Len is 3, that's right. Is a constant pointer to an array of U8. Pointer cast to the address of terminated. The third spot, or I guess the third index, is equal to 0, which will be true because that's what this is terminated by. Yep. Um, ah. The types of string the types of string literals are a pointer to a constant array of U8, n terminated by 0, where n is the length of the string. This allows string literals to coerce to sentinel terminated slices and sentinel terminated many pointers. They are UTF-8 encoded. I guess all of that's kind of important. And our UTF-8 encoded. Type of string literal where n is the length of the string. Which allows string literals to coerce to sentinel terminated slices and sentinel terminated many pointers. They are UTF-8 encoded. Okay. Okay. So type of hello will be a pointer to a constant array of U8, size 5, 1, 2, 3, 4, 5, terminated by 0, which in this case is null. So the actual string is that. And then it is a U8 because it's a string. So that will pass. Pointer to null and pointer to null const are perfect model C strings. So that works with interop. I'm just going to put that here. Let's work with interop. C string. Yep. Well, it does not equal 0. So that's just going to copy it. So if we std.debug.print C string versus array, not what I want. Those will be the same. Sentinel terminated types coerce into their non-sentinel terminated counterparts. I really should put like a mark here. Do I use marks again? Okay. Vim go to mark. Using mark. Okay. So if I go here and then here, okay. That's gonna make this way better to look at. And then I'm also going to put one here. So yeah, much better. Course two that are non-sentinel. So this is equal to a set of BDF, which are the unused ones. And they coerce to their non-sentinel terminated. So you can get rid of the sentinel terminated, like the sentinel termination, I guess. Does it work the other way? So if I had, what am I doing? So if I had const g is equal to undefined, and then, oh my, what am I? I'm struggling. A, B, C, D, E, F, G, H is equal to that. Unused local constants. That's fine. So that does appear to be fine, I guess. Which makes sense. Sentinel terminated slicing is provided, which can be used to create a sentinel terminated slice with the what the sentinel terminated slicing is provided, which can be used to create a sentinel terminated slice with the syntax slice to termination, slice to value terminated by. Doing this is an assertion for the programmer that the memory is terminated where it should be. Okay. That was really hard to read. So inferred length to null U8 value 255 times 3. So this is going to be 255, 255, 255. And then y is going to be a slice from 0 to 3. So the whole thing basically. Terminated by 0, which if I made that 1, would that still work? Expected. Okay. So it does not work both ways. Doesn't work both ways. Cannot coerce non-st to st. And then we will just get rid of that. Panic sentinel mismatch, yeah. Sentinels must be the same. Okay. But non-st coerce to st, and then sentinel values between variables between what the fuck? Interacting variables must be the same. Which, yeah, fair enough. Vectors. Single instruction, multiple data. Okay, yeah, okay. I am going to call it here. That is a lot of information to take in. None of it is super crazy or anything. It's just a lot. So yeah, I don't really have anything to say. If there is anyone here, thank you for lurking. If not, well, you know, um, with that, I will end the stream. Goodbye.